Hello, welcome to my talk, Best New Features in .NET Test, Microsoft Testing Platform, and MSTest. I'm Jakub, and I'm here on behalf of the .NET Testing team, and I'm super happy to be able to show you the latest, newest features that we're shipping in Net 10. So let's get into it. First, .NET Test and Microsoft Testing Platform. In .NET 10, we shipped a completely new view that enables you to see results of your test in more interactive, more nice way that is more colorful and more usable than before. This is a demo-driven presentation, so I will be switching directly into my VS Code. And in here, I am having a solution that has 3 different projects: MSTest, NUnit, and xUnit, because Testing Platform supports all major testing frameworks, also Expecto and TUnit. First thing that I want you to see is that we have global JSON, and in global JSON we have this new configuration. Under the section Test, we have the runner option, which is set to Microsoft Testing Platform. This is needed to enable the new .NET Test mode inside of Net 10. Don't worry, there is IntelliSense provided, so you don't have to remember this. You will get suggestions if you try to create this file. I will switch to my run PS1, it will clean my screen, and then it will run a simple command, .NET Test. So let me run that right now. My solution builds, and we can see that we have some progress bars that are showing the progress of the test running, and this is directly inside of .NET Test. Some assemblies now finished, and now the whole run is completed. So let's scroll up and let's see what happened. First, we have an overview of all the DLLs that were executed in this run. In this case, we have 3 different DLLs, all targeting Net 10 and x64 architecture. But if we had multiple architectures or multiple target frameworks, or even more DLLs, we would see all of them listed here. Then the first run finished the first DLL, xUnit test project finished, and then we had the single method, the single failing method that we have in this run, which is test method 100 coming from our MSTest project. We have a preview of the failure, and we also have the information from which exact DLL, which exact TFM, and which exact architecture the failure came. In case you have code that's specific to a TFM, this is very useful. Then we have the full call stack of what happened, and then we have our standard output. In this case, the failing test is outputting our little .NET bot into standard output saying I love .NET 10. Then we had no additional error output, and then the NUnit DLL finished, and then we have also the summary of the MSTest DLL, which failed with 1 error. All the other DLLs passed because we didn't add any failing tests into them. And we also collect and write the standard output of the MSTest executable, which says exit code was 2, this is the standard output, and everything that you can see about the run. Now those test results and those DLLs can finish in different order, in different place, so the output can be quite long. So underneath that, we also want to give you a quick summary of the whole run. In this case, we can see that the run failed, and then we have a summary of each DLL listed as they go, together with how many errors they encountered or if they passed. After that, we have the summary of the whole run. So in total, we ran 30,000 tests, 1 of them failed, and none of them were skipped, and this took 9 seconds. After that, the result of the overall run is printed. In this case, we exited with exit code 2, which means at least 1 test failed. Now the new UI in .NET Test is not just about the new colors, the new things that you see on the screen. It also makes Microsoft Testing Platform more native to .NET Test. To see that, we can switch to my second demo, and in here I will run .NET Test help. I have a project that installs a new extension, and extensions in Testing Platform are installed as NuGet packages. So here I have my retry NuGet package with the retry extension, and this extension adds the ability to retry failed tests. But how do I learn about what the retry can do? I can run .NET test help, and it will list all the options that are available. In this case, those are the options for the retry plugin. So retry failed tests, retry failed tests with max percentage, and so on. And this goes beyond this. If we would have multiple projects and they would have incompatible extensions, then the .NET help would print a warning that would say this is available in one project and this is not available in a second project, giving you opportunity to solve problems before runtime. So let's run this test. In this case, I want to call this code, so run with retry failed test and output detailed. What this will do is it will retry my failing tests at maximum 2 times, and then the detail output will also show me passing tests to make it a bit easier to understand the behavior. So in here I have a test that never passes, and it indeed fails. Then I have a test that passes on a second try, but not on the first one. And you should notice that we have native support for this kind of retry plugin where we tell you on which try the test passed or failed. And then we are trying the second try, so the first retry. The test passes, and so we will no longer bother rerunning it. But the other test that always fails is still here, and we continue and we retry it one more time, so that's the second retry. And the test again fails, and the whole run concludes and fails. We also get this summary where it tells us what exactly happened, where, and how many tests passed or failed. And in the final summary, we can see that total test 2, so that's 2 tests in each run, and then we had 3 additional retries tests. Why this doesn't say total 5 is because we want you to see in the last result a comparable amount of tests if you tried 1 time, 3 times, 10 times, because usually in production the tries are not very deterministic. Your network doesn't always fail the same way, and so on. Now, one situation that can happen is that you make some mistake, some systemic error that will fail all your tests. And what you don't want to see is that you retry 100% of your tests for 4 times. So we have this option that's called retry failed test max percentage. I will comment this out or uncomment this, run it one more time, and if more than 20% of my tests will fail, I will no longer continue retrying. So in this case, my first test and my second test fails, so that's 100% of my tests failing, as documented here in this line. And so there is no point in me trying further to retry my tests because this is too much failure for me to even ever be successful. So that's our plugin, but we have more plugins and we have more features that make testing, running your tests in CI more approachable. So what I want to show you now is that I will switch to another repo. And here in README, I will switch to my GitHub actions of this repo. And I want to show you that we now output colors inside of the Azure DevOps and GitHub actions output. So in this case, you get the progress, which is nicely colored. You get the error, which is nicely colored. Much easier to see where the test failed now. This also applies to Azure DevOps. So let's open Azure DevOps, and in there, we again see a failure. We see all the colors. We see all the progress bars. And it also now focused this line, but this line is not enabled by default. This is another plugin that we've installed into this project. So I will navigate there. Here we have this Azure DevOps report. And what this extension does is if you build on Azure DevOps, but you actually store and develop your code on GitHub, it allows you to see errors directly in your pull request. So I installed this extension. I also added this parameter, report as though, into my Azure pipelines. And then if I navigate into my pull requests on GitHub, where I've added a test that fails on purpose, I can see that it automatically reports it directly underneath the line of where it's failing. Unfortunately, the formatting here is not working so great, but if you switch to checks, you will see all the errors as they were reported from the run, and this will save you a trip to Azure Pipelines, finding where the error is and so on. So I find this super useful. Now this is all that I am able to show you about .NET Test and MTP, but if you would like to learn more, because there is more, then please go to this link that is on DevBlogs describing all the new things that are in .NET Test. If you would like to learn more about our extensions, please use the second link to learn more about our extensions. Now let's move on to MSTest. In MSTest, we've been quite busy in the past year. We were able to release 5 minor versions, and I'm happy to announce that we also released one major version, MSTest version 4, which is now available on NuGet.org. If you would like to know everything about the new features, how to migrate to it, go to mstest/migration v4. And now let's look at the newest things that we've added in analyzers, assertions, and attributes. So I will switch to my demos because I have quite a few of them. So first let's look at analyzers. Analyzers will analyze your code as you type it, and they will point out any potential mistakes that you've made in your setup to make sure that your tests will be able to run when you actually run them. But first, I want to point out this meta package. If you install MSTest, if you use MSTest, definitely use this MSTest meta package, which is bringing all the dependencies, everything that you need together. Previously, you might have installed MSTest Test Framework, MSTest Test Adapter, Microsoft NetTest SDK. All of this is included with the appropriate versions. Just install the latest version of the MSTest meta package. This MSTest meta package also brings the analyzers that we've been talking about, and one new analyzer is looking at the data rows, and it points out any duplicate data row that you have. We've seen with multiple teams after implementing this analyzer that they found tests that were incorrectly duplicating the tests, and this typically happens when you copy paste from one line to the other and forget to change the item, in this case the last item in the list. I forgot to change it from admin to user. So now I'm not testing what I was expecting to be testing. The analyzer points it out for me, and it shows me a warning during build or as I type the code. And I can see that there's something wrong and I should go and fix it. But unfortunately, not all analyzers that we add can be warnings for historical reasons, for compatibility reasons, and so that's why we added analysis mode. In analysis mode, you are able to opt into a more stricter analysis mode where we apply all the rules as we think they should be. So you can enable it once, fix all the errors once, and then continue improving your code with this more strict approach. So in this case, I'm using MSTest 3.11, which is now quite outdated, and I have 2 test classes which are incorrect. One of them is a test class which has the attribute on the class, but it doesn't have it on the method, and I get no warning, but those tests wouldn't run even though I probably wanted them to run. And secondly, I have a test class which doesn't have the test class attribute, but it contains a test method. This is potentially a base class, but in that case, if it's a base class, it should be abstract, but this is not a pattern that we commonly see used. We commonly see a class that just misses the attribute, and we don't think that's the correct approach. So what I can do now is that I go into my project and I set the analysis mode to recommend it. And when I save and build, I will see the warnings kicking in, and I will see the warning for the test method. Do I? here I go. So here I see the warning for the test method that it should have for the test class to have the test method marked with the test method, and then I see the warning for the test class to tell me that it contains a test method, but it should be marked with test class. So this prevents me from losing my tests, and again, we saw those patterns being improved in multiple repos after applying this analyzer. Now, one more way to look at analysis mode and at analyzers is that it pushes me towards better practice, and then I have easier time upgrading to newest and newest versions of MSTest. So for example, if we look at my second class, we have this expected exception attribute. And in this case, I'm using MSTest version 3.8.0, which is quite old. And it still has this attribute. We removed this attribute in version 4. So if I would upgrade directly from this version to version 4, I would get a compile time error that would prevent me from building. But what I can do is that I enable my analysis mode proactively. And then if I go into my code, it will tell me there is something wrong with this. Please prefer using throws exactly over the expected exception. And I can also Control-click this, and I will get a quick fix that I can apply to my document, to the whole project, or even the whole solution that will fix this problem for me. And what will happen is that it will remove the expected exception, as we see in the preview. And so then when I update to MSTest version 4, I will no longer have a problem. So my path to upgrade to MSTest version 4 is much smoother, and I have less problems as I go. In this case, I also get a second warning which says don't use throws exception. Instead of that, use assert throws exactly or assert throws. We replaced assert throws exception with assert throws exactly in version 4, and we've deprecated it. And so that's why we don't want you to use it anymore. And the analyzer again points this out. So you have a smoother path. And if we eventually decide to remove this pattern in version 5, probably, you will not hit a compile time error if you follow the recommended analysis mode. Now let's move to assertions. So in assertions, we did quite a lot of changes. We improved some assertions, we've added some assertions, and one of the things that I really like is that we've added this nice little arrow that points out directly where the difference is in assert are equal. I've run my tests and I'm comparing hello net10 to hello net09, and now the arrow points for me exactly where that difference is, so I have easier time seeing where the difference actually happened inside of the strings. This is a small quality of life upgrade, but I really like it. Then we've added is greater than, so you can use that to compare numbers, but you can also use it to compare any different comparables, like strings in this case. We are expecting A to be greater than B, but it's not, because A is smaller than B, and then I get an error that describes exactly that. We also have is in range. You provide a range of number or a range of comparables, and then you can compare it to an actual number. So we expect 11 to be between 0 and 10, and it's not there. That's why we get an error that tells us this doesn't fall into this range. And then lastly, a whole new category of assertions. We have assert that, which allows you to provide a callback as an expression, and then it will analyze the expression, find the identifiers inside of that expression, find what the value of them was, and print that to the screen. So let's see that run. Here in the failure, we can see that this expression was evaluated, so expected name equals the username, and it failed. And then we get the values that were actually under those identifiers. So the expected name was Bob and the username was Alice. And this way we can provide more complicated, more complex assertions to the test framework, and we would get back the values that were evaluated, and we also don't lose the context of what's actually being said in the assertion. So we can immediately see that we had an expected name and we compared it to the other name. So we find this quite useful, and we hope that you will find it useful as well. Now, the last thing that I want to show you is conditional attributes on tests. In this case, we have this OS condition, which says this test should run on Windows, and this test should run on Linux, something that we quite use in our own CI to be able to conditionally run tests on different OSs. And then we have another condition which says exclude Windows, so run on everything that is not Windows. In this case, I am on Windows, so if I run my tests, I should see only the first test running, because that one is selected for Windows. And that's exactly what happened. So test method number 1 was running. Test method number 2 is only supported on Linux. Test method number 3 is not supported on Windows. So those tests were skipped and this one ran. But this is not limited only to OSs, because the OS condition is implemented on a base attribute that you can extend. And that's exactly what I'm doing in my second test. I created this emoji condition attribute and implemented it as follows. I derive from condition-based attribute. I provide the emoji and save it. And then I don't support the exclude mode just to make it easier to see the code, but it would be quite easy to implement that. Then I give a group name, which is required, and in this case it's emoji condition, so I can then see it in the output. And then I have finally the condition under which the test will run. So in this case, if the emoji equals to thumbs up, we will run, and if it's anything else, then we will not run. Now we can try to run my tests, which are decorated with thumbs up, so this one will run, and with thumbs down, this one will not run. And that's exactly what we see happen. Test method number 1 is running, and the second test method is not running because it has thumbs down. So we think you can customize this and you can use this to all kinds of different things, checking if you should be running in this environment, if you should be running on this architecture of processor, and so on. That's why we made it extendable, so you can come up with your own cases. But if you find something that you think that it should be really built into the test framework, let us know. And that's everything that I had to show you through MSTest. So we have analyzers, we have migration. Please navigate to those different links if you want to learn more about everything that's available and how to migrate to version 4. And the last thing that I want to talk about is performance. In MSTest, we did quite awesome performance improvements between version 3.10.3 and 3.11. What we can see in this chart is an execution of a test suite that has 200,000 tests. Quite a large test suite, and it really depends on how the tests are laid out in classes. In the slowest case, that took almost 60 seconds to execute, we have 100 classes with 2,000 tests each. In the middle, we can see 1,000 classes with 200 tests each, probably the most realistic example that we have here. And then in the fastest case, where it took almost 9 seconds or 8.1 seconds, we have 20 classes with 10,000 tests each. But in 3.11, after the optimizations, all of those cases merge together and they execute in 5.5 seconds. And this optimization, of course, carries over to version 4, where it takes almost the same time. This doesn't translate just into time savings, it also translates into saving memory traffic for allocations, which makes your garbage collector less busy, and so your code executes faster. And that's all I have for you. So in summary, we really look forward to you trying our latest features, latest versions of our products. We really want you to update to the latest because we want you to have the greatest and the fastest version of our products. We're looking forward to your feedback, to the problems that you encounter, and to the ideas that you want to share with us. And we are listening to them on github.com/Microsoft/testfx. So install .NET 10 today, enjoy the new .NET Test view, and let us know what you think. Thank you for listening.